Right. Welcome back to the deep dive. We're going to be diving into a topic today that, honestly, it's something we should all be more aware of. We're talking about chemical hazards.
Chemical hazards.
Yeah, and the crazy thing is, we encounter them more than we think.
Yeah.
You know, you walk into work, you think, okay, it's a safe environment. But are there unseen dangers? What don't we know about?
Right. And that's what we're going to unpack today using a training workshop document as our guide.
That's right. We've got this great document here all about chemical hazards communication.
Lots to talk about in there.
Yeah.
So much stuff.
So much stuff to dive into.
Yeah.
How to identify them, what risks they pose, the forms, the classifications, the routes of entry.
Yeah, and how that information is conveyed.
And how all of this is communicated. You know, you see these SDS sheets, you see these, warning labels, and what does it all mean?
Totally.
What does it all mean? So let's start with the basics. When we say chemical hazards, what exactly are we talking about?
Well, basically, it's any element or compound that you might encounter in your workplace, whether it's natural or manufactured.
Okay.
These chemicals can cause harm. Obviously, to the environment, we know that pollution and all that, but also to our health, it can lead to some pretty serious illnesses, potentially.
So it's more than just, this is explosive or, something like that.
Oh, yeah.
But they're different types.
Yes,
right?
Yeah.
How would you kind of categorize them, these dangers?
Well, I mean, broadly, you can group them into, your physical hazards, right?
Yeah.
So those are things that are flammable, explosive, combustible, compressed gases.
Right.
And then you have your health hazards, which are things that are toxic, corrosive, irritant, carcinogenic.
Right.
Harmful. Lots of bad stuff.
Yeah. And these materials, these chemical hazards, I mean, they come in all kinds of different forms.
Oh, absolutely.
I mean, what are some of the forms that we might see them in?
So you have things like dust, right? So you think about working with flour, if you're, in a bakery or something, or certain rock dusts.
Got it.
You have fumes. So these are often tiny particles of metals that are created during welding and other high heat processes. And it's important to note that inhaling certain welding fumes over time can lead to some serious, lung issues.
Right.
Then you have gases, which are, just naturally in a gaseous state. You have mists, which are little tiny droplets of liquids in the air. Vapors, which is, you think of like a solvent.
Right.
And then, just straight up solids.
Yeah. Now, why does the form matter? I mean, it's the same chemical, but how does the form impact you?
It's all about how it enters your body, right? So dusts, you can inhale them deep into your lungs, especially the fine particles. Fumes, you breathe them in. Vapors can enter through your respiratory system.
Okay, so different forms means different entry, different exposure.
Yes.
Got it.
Exactly.
Okay, now how do we actually classify or categorize all these different chemical materials? I mean, it sounds overwhelming.
Well, yeah, I mean, you have, when we talk about dusts, for instance, they can be organic, inorganic, they can come from plants or animals, or they can come from minerals and metals, like silica or lead. Fumes are generally from those high heat processes, smelting, combustion, that sort of thing.
Right.
Gases are gases, and then vapors are the gaseous form of substances that are, a liquid or solid at normal conditions. So if you heat them up or reduce the pressure, or, air currents can cause them to vaporize.
Right.
Then you have explosions, which are, just sudden releases of energy. That's a whole other thing.
Right. And what about gases and vapors specifically? I mean, how are those categorized?
Well, they're often grouped by their effects, right?
Okay.
So, you have your organic solvent vapors,
Yeah.
Things like acetone, benzene, carbon tetrachloride, xylene, carbon disulfide, alcohol. You have irritants of the upper respiratory tract. So that's things like ammonia, acetic acid, sulfur dioxide, formaldehyde.
Yeah.
You have lung irritants, so things like fluorine, phosgene, carbon dioxide.
Okay.
Then you have simple asphyxiants. So these are things that displace oxygen, like nitrogen, methane, carbon dioxide, inert gases.
Right.
And then you have chemical asphyxiants. These are things that actually react with your blood.
Oh, wow.
Like carbon monoxide.
Yeah.
Or things that inhibit the use of oxygen by your cells.
Right.
Like cyanide. You also have toxic gases, which are absorbed in the blood. So these are things like phosphine and arsine.
Yeah.
And those can, really affect different organs.
Right.
And you have anesthetic gases, which dissolve in the blood and can affect the brain. Things like nitrous oxide.
So there's all different kinds. I mean, there must be some sort of general way to classify these chemicals by their level of danger.
Right. Yeah. So, and you look at the chemical effects, right? So is it highly flammable? Is it explosive? Is it an oxidizing agent?
Right.
Then you have the health effects. How toxic is it? Is it carcinogenic? Does it cause asphyxiation, corrosion, burns, irritation?
Wow.
And then you have the environmental effects, Is it harmful to aquatic life or agricultural life? So, yeah. Specifically, when we talk about the health hazards, you have different classifications there. You have toxic, which means even small doses can, cause death or other effects.
Right.
You have harmful, which can, lead to death through inhalation, ingestion, or absorption. Corrosive or alkaline, which, destroys living tissue on contact, like concentrated sodium hydroxide, for example.
Right.
You have irritant, which causes inflammation of the skin or mucous membranes or the lungs with, prolonged contact, like ozone, for example. Carcinogenic means it, may cause cancer. Asbestos causing abnormal cell growth. Sensitizers, which can, trigger allergic reactions. And those actually worsen with the repeated exposure. So, you got to be careful with those.
So how do all these dangerous materials, how do they actually get into your body and cause harm?
Well, the main routes of entry are inhalation.
Okay.
So breathing it in.
Right.
Ingestion, swallowing it.
Yeah.
Skin absorption, going through your skin. And even injection.
Wow.
And depending on how it gets in can determine the effect.
Right.
So, like breathing in carbon monoxide can lead to asphyxiation.
Right.
You get skin contact with a strong acid, you're going to get a burn.
Right.
Asbestos, if you inhale it over time, that can lead to lung cancer.
Right.
So, yeah.
So occupational exposure, we've mentioned that a couple of times. What does that actually mean?
It just means, exposure to these chemicals in the workplace.
Okay. So in the workplace. Got it.
Yeah.
Now, we also mentioned earlier, these occupational exposure limits.
Right.
What do we need to know about those?
So these are, legal or recommended maximum levels of these pollutants in the air.
Okay.
To protect workers.
Okay.
So there's long-term exposure limits, which are basically, it's okay to be exposed to this much over your working lifetime.
Right.
8 hours a day for, however many years.
Right.
Then there's short-term exposure limits. So these are for brief exposures, intermittent exposures.
Right.
And then there are ceiling limits. So those are, these should never be exceeded, even momentarily.
Wow.
And these are measured in units like milligrams per cubic meter, parts per million.
Wow. Okay. So what are some of the things that affect how much these pollutants actually impact you? How does it actually, harm your body?
Well, it depends on a lot of things.
Mm-hmm.
How concentrated is the chemical?
Yeah.
How long are you exposed? How fast are you breathing?
What's the right of entry? How big are the particles? If it's dust, what are the properties of the gas or vapor?
Mm-hmm.
Is it really soluble? Is it really chemically active?
Wow. Okay.
Then you have the individual susceptibility.
Yeah.
Some people are more susceptible than others. And then just the efficiency of your resistance system.
Right.
How well your body defends itself.
Yeah. This really shows why managing these risks is so important. Where does it start? How do you manage these things?
Well, it starts with a hazardous materials inventory.
Okay.
So this is just, a list of all the hazardous materials that are present at the workplace.
Okay.
And you should know, what form are they in? What's their nature? What are the health effects?
Right.
What are the routes of entry? How concentrated are they? Who's exposed? How long are they exposed? All that good stuff.
Mm-hmm.
And then you need a list of threshold limit values, ceiling limits.
Right.
And you need procedures for all your different activities.
And then, the safety data sheets.
Right. And all this feeds into a larger system, doesn't it? How do you kind of, make all this information accessible to the people who need it?
Right.
To keep everyone safe.
So the goal is to have a hazardous material information system.
Okay.
And this ensures that everybody who needs to knows how to safely handle, transport, store, and dispose of these chemicals.
Right, right.
So this system is going to include, the chemical inventory we talked about, the SDS for each substance, clear labels on the containers, and training and information dissemination, making sure everyone is informed.
So let's focus on those SDS, those safety data sheets. I mean, what kind of information, what kind of useful information can you find in those?
So an SDS is basically, a detailed safety manual for a specific chemical.
Okay, got it.
So it's got 16 sections covering everything you need to know for safe use. It starts with the identification of the chemical, the hazards identification, composition information, first aid measures, firefighting measures, accidental release measures, handling and storage, exposure controls, personal protective equipment, physical and chemical properties, stability and reactivity, toxicological information, ecological information, disposal considerations, transport information, regulatory information, and other information. So it's a lot.
It's very comprehensive.
Yeah.
It is.
It's all in there.
Okay. Now, what about those warning labels you see directly on the containers? I mean, what do they tell you quickly?
So warning labels provide, immediate information about the main hazards.
Okay, got it.
So you might have the NFPA diamond, right? Which is, it's got 4 colored sections.
Got it.
So blue for health, red for flammability, yellow for instability, and white for special precautions.
Right.
And then they're rated from 0 to 4, indicating the severity.
Right.
So, blue 4 means, severe health hazard.
Sure.
With short exposure. Red 4 means it burns below room temperature. Yellow 4 means, may detonate at normal conditions. And then the white includes, symbols for special precautions. W means it reacts with water. OX means it's an oxidizer. SA means simple asphyxiant. That kind of thing.
Okay. Are there other kinds of warning labels that you might encounter?
Oh, yeah. So you also have the HMIS label, which is similar to the NFPA, but it's, it's a rectangular format.
Yeah.
And it includes a white section for the Personal Protective Equipment Index.
Okay. Got it.
So those are also rated 0 to 4, and they also have letter codes that tell you what PPE is required.
Right.
And then you also have RTK labels.
RTKs.
So to know labels.
Okay.
And those can be very comprehensive. They list the hazard types. They show the PPE, what parts of the body are affected.
Right. How
to control fires, first aid, spill procedures. Yeah. And they often use pictograms, right?
Right.
Which are just symbols. So like a little flame means, fire hazard. A test tube pouring on a hand means corrosive. A gas cylinder means compressed gas.
Right.
Skull and crossbones obviously means acutely toxic. An exclamation point means, health hazard. A circle with a flame means oxidizer. A bomb exploding means explosive. So yeah, all those different kinds of things.
Well, this has been really, really informative. I mean, I think a lot of us take for granted the potential dangers that are around us.
Right.
So just to recap, we've covered the different forms and categories of chemical hazards.
Yep.
The importance of knowing how they can enter your body and the safety limits that are in place.
Right.
And the crucial role of SDS and warning labels in communicating these risks.
Absolutely.
And I think it's so important to keep in mind that this information's out there. It's accessible to us.
Yeah.
And it's just a matter of being aware and educating ourselves so we can make safe choices.
Totally. I mean, it's all about empowering people, right?
Exactly. So as you go about your day, just think about the products that you use, the environments that you encounter.
Yeah.
How can this knowledge about chemical hazards, how can it help you assess the potential risks that you might be exposed to and make safer choices? Take a look at some of those labels. See if you can find an SDS sometime.
Yeah.
And learn more about the chemicals that you're working with. It's a great way to stay informed.
Absolutely.
And thanks for diving deep with us today.
It's been a pleasure.
Yeah, it's been a blast. All right, we'll see you next time.